Okay, so here, this is a piecewise integration problem. What's the first thing you should check for and hope for? Continuity. If it's continuous, what's the benefit of if it's continuous?
You don't have to do limits.
You don't have to do limits. So, if this is this continuous?
Yes.
It is continuous. They both meet at 0, so you can just straight up integrate from -1 to
I
0.
have a question.
Penny,
Do you have to show continuity or can you just?
you don't. I want you to check it, and you'd be foolish not to, but you don't have to prove it or anything.
So how do you know if it's just?
So this is what we did the other day. So let me just give you a quick rundown. If the graphs didn't meet there, for example, it was only defined for the left side and not the right, and I was doing region from -1 to 1. -1 to 0, I could do a normal integral because it's defined all the way up to and including the endpoints. But for this side, I would then have to do a limit as a goes to 0 from above, of 0 to 1, and because of the discontinuity, you know what I'm saying? So if the pieces, if the pieces don't meet, you're going to have to do this limit approach.
It's from 0 to the right, the ones that we can get left out, right?
Yeah, exactly. Yeah, because say this, it wasn't included on the right-hand side. Because of that open circle, that's
But
why.
then this one, you know, like.
This one, because they actually, so they all checked continuity mentally. At 0, this is 0. At 0, this is 0. They're meeting, so there's no discontinuity there. There's no limit. Okay? All right. So, are you good from there, I assume? Yes? Make sure you anti-differentiate that rather simple, but it's got a little bit tricky there. It's negative cosine. So did you get 0 minus a half plus negative cosine of 1 plus cosine of 0?
Yeah.
So maybe 1/2 minus cosine 1. All right. So the lesson won't take more than 10 minutes, and we'll move along. It's an important one, though. So we talked, I guess it was 2 days ago, about conditional convergence and absolute when you get negatives in it, right? Does that sound familiar?
Sure.
You remember Wednesday?
Yeah.
Okay, good. Okay, well then, Wednesday. Wasn't it Wednesday?
No, it's Tuesday.
Tuesday?
Yeah.
Yeah. Oh my, what a long week it's been. Okay, so, do you remember that an alternating negative helps convergence? Yes? Okay. Also, do you remember in terms of just really vocabulary, if the alternating series doesn't even need that negative to help it, it would converge without the negative, but that's called absolute convergence. And to investigate that, you would say, if I took the absolute value of that, remove the negative and look at convergence, if it converges anyway without the negative, then it converges absolutely. If, however, it doesn't converge absolutely, it could still converge with the help of the negative. That's called conditional convergence, and that's what we're going to prove today. All right. So the good news is it's really easy. It's probably the easiest of all to prove. It's really a low bar to meet. To prove conditional convergence, you really just have to check 3 boxes. First of all, it only applies to alternating series. So is the series an alternating series? You don't do conditional convergence on a positive term series. This is only for when the negative's there, what happens. You with me? Okay. The second thing is the terms have to gradually decrease in value. I'm going to draw a picture in a second to help illustrate the point. But only if the terms decrease in value will you gradually spiral in towards a limit rather than spiral out towards positive and negative infinity. And then last but not least, the terms also have to still pass divergence there. You have to be adding smaller and smaller terms approaching 0 to have a chance of having a sum. Now then, let me show you a picture to help communicate why these things need to be true. Imagine if we looked at a partial sum graph, so that as I added more and more terms, I would chart the partial sums of the first term, second term, and so on. Say the first term was some positive number, okay? Now then, if it were alternating, then after that first positive number, the second term would be negative. and therefore overall decrease the partial sums. I'd get a partial sum that was less than the one terms, right? Now in terms of the gap I just created, I got a lesser sum here, or the sums went down here because that second term was negative. So you could actually say that this distance that it decreased by is actually what that second term must have been. Are you with me?
Yeah.
All right. Now then, if the terms are decreasing, then the next time it goes up, it should go up by less than it went down, because the magnitude of the numbers I'm looking at are less. So it'll go up by a little less. And then if the terms are, the numerical values are decreasing, then the next time it goes down, it'll go down by a little less than it went up. And then it'll go up by a little less than it went down previously, and that's what causes it to spiral in towards our limit. You with me? All right, now that's the thought process behind why it works. Now, I'll just show you really quick how easy it is to prove conditional convergence. If we were to show the alternating harmonic series converges, does the alternating harmonic series converge absolutely? Why not? Because if we did it absolutely, we'd look at the positive. The positive is the harmonic, and the harmonic diverges, so it doesn't converge absolutely, right?
Yes.
Okay. Now with the negative, however, it will. We can show that. So to show conditional convergence, this in my mind, absolute convergence was no, because harmonic diverges. But I could prove it conditionally converges just by saying, first of all, is it an alternating, actually let's write the series here. Let's say this is what I'm looking at. Is it an alternating series?
Yes.
Check, okay? It meets that condition. Basically, I know it's tedious to write it when it seems like it's being given, but you need to communicate, hey, I know this is the first condition. It has to be an alternating kind of series. Second, do the terms decrease? To show this, you really just, it's a lot like the inequality work we've done before. Wouldn't you agree that n plus 1 is greater than n?
Yeah.
Wouldn't you also agree that 1 over n plus 1 is less than 1 over?
Yes.
Didn't I just therefore show that the absolute value of the terms, isn't that the n plus 1th term that's less than the nth term I just showed? I basically just showed the terms decrease, right? 1/4 is less than the one before it, 1/3, so on. Right? I also could easily show that the terms are going to 0. In other words, the divergence theorem is passed. Do the terms, if you go infinitely many, forget the negative. It doesn't matter about the -1 going back and forth. I'm talking about -1 divided by 1,000,000,000, and then +1 divided by 1,000,000,001. Do those go to 0? They do. So, those three conditions are met. That's all you have to show in order to conclude that n must converge conditionally. It's pretty easy standard to use. You follow? Okay. Just getting you a little bit of different questions asked us differently, depending on your textbook and such. So one question might read this way. Does this converge absolutely, or show it does not converge absolutely, but it does converge conditionally? Well, how will I show it does not converge absolutely? I need to show that the positive diverges. So I will look at the positive version and say that would just be that. If I took the absolute value, remove the negative, does that converge or diverge? This diverges because why? P series with P equal 1/2 less than or equal to 1. Because of that, the alternating series does not converge absolutely. If it doesn't converge without the negative, then the alternating series does not converge absolutely. You with me? Right? So I proved the first part of the question, does not converge absolutely. Now the conditional part. Yes, ma'am.
So if it doesn't say, like, show that series does not converge absolutely, do we have to give a whole explanation?
You don't.
Okay.
You just, I mean, often the question will just be, does it converge or not? And you can actually say, well, I could do it absolutely, or I could do it conditionally. And it's up to you. Okay. So in this case, then we're going on to conditional. What are the three conditions I have to show are met?
So it's alternating.
It's alternating. First of all, say, I know that this needs to be an alternating series. Check. Next, you need to show that the terms decrease in value, or the next term is less than the one before it. Start with something obvious like n plus 1 is greater than n, and build towards what you're trying to prove in this problem, which is the square root of n plus 1, and so on. So, where do I go from here? Square root. I can square root next, which that maintains the inequality. I think that's still true. I know that's still true. Flip 1 over root n plus 1 is root less than 1 over root n. Now, when I do the direct comparison test, I then bring in the series, right?
Yeah.
We don't do that here. I'm just trying to show the terms are less. So that's done. I showed that the terms are getting less. Now, the absolute value is there because I don't, depending on if it's positive or negative, that could get dicey. The number could get smaller, but because of the negative, got big. So we don't care about the sign. You with me? All right, last but not least, do the terms go to 0? That's a yes. So all three conditions are met. So I can conclude the series converges conditionally. That's it. All right. So kind of what Cece was getting at. What if the question just said, does the series converge? Could you prove this converges absolutely?
Sure.
You could. By comparison test to the geometric, you could prove it converges absolutely, and therefore converges. So you could go that way, but just for the practice, would you just prove it conditionally converges instead for the practice of conditioning? How's it going? I assume it's great. Should we try the ones after homework? Okay. No?
Do you go back to it?
Sure. All right, so on the homework, tonight's homework, you're looking at numbers, or at least one or two. Let's say, oh man, number 10 we already did.
Oh, man. Wait,
I
what?
should, I kind of just did it in my notes. Let's change it a little, shall we? All right, never mind, I'll just say it.
Okay, I'm good. You can change it.
Okay. All right, so 10, the question is just converge or diverge. Actually, no, I didn't say that right. The question is, determine that it converges absolutely converges conditionally or diverges. Okay, so number 10 is -1 to the n plus 1 times 1 over n. Actually, I'm going to put that in my notes.
So could it converge absolutely and conditionally?
Yes.
Okay.
How'd it go? Good. Should we do one more or call it good?
Let's do one more.
All right. How about, let's go with 15. Actually, let's go with 12. Sorry, 12 is fine. Okay, so I want you to waste your time going too far with 12. Actually, we will do 15 also. Sorry, but let's look at 12 first. What do you think?
Well, it's alternating.
That's true. Okay, so don't forget your first steps. Yeah, the first thing you check: alternating, diverging, positive, negative, absolute, all that. The first thing is always do the terms go to 0. They do not. The limit of the terms.
Because exponentials are
N to the third is stronger than 2 to the n.
So
No, other way
Just be n is stronger.
except
If
for
you're putting something to the end, it's stronger.
Yeah. 2 to the n dominates the n cubed, so the terms would go back and forth between positive and negative infinity, which is definitely not 0. And therefore, the series diverges. Now, after that, then it's a moot point. It's not going to diverge, but converge absolutely. Or diverge, but converge. There's no converging.
When you do the divergence theorem, do you have to say that infinity does not equal 0? Or can you just say equals plus or minus infinity, therefore diverges?
That would be sufficient. Okay. If there were a number there, I would suggest 2. If it was the limit was 3, then I would then say it's not. Okay. Let's do one more just for the fun.
Wait, so now it's done.
You're done. If it diverges, then there's no
You can't
question.
make it converge myself.
It cannot conditionally converge. Okay. So let's talk. Let's go here. Let's talk Venn diagram, shall we?
Yeah.
Actually, it's let's go. There are 2 disjoint sets. Okay. Really?
You just asked me stuff. I had so much.
Really? Venn diagrams?
No, like those weird problems, with like people as a class, and then there's like a Venn diagram in the middle, and then
Oh.
different subset of people, I thought was wrong.
I think they're so valuable in explaining how things relate to each other, groups relate to each other. Okay, so first of all, there is no such series that is part of both the divergence set and the conditional or any kind of convergence set. You cannot be diverging but also converging in any fashion. That's not possible. Understood? It is possible to be absolutely converging and conditionally converging. Can you give me an example of one?
One on the earth and
That's perfect. That would converge absolutely. It wouldn't even need the negative, but it could easily be shown converging conditionally with the negative. It also converge. Can you give me something in place A? That would obviously be conditionally convergence, but not absolutely convergence. Yeah, the harmonic series, alternating harmonic series. That would be true. And then, you with me? So you can't diverge and converge in some way. That doesn't happen. All right, 15. 15, I would normally hit that in a geometric kind of, in a geometric way, but they asked me to do all this conditional, absolute kind of work, so let's go for it. -1 to the n, does this converge absolutely? That would be if I took the absolute value. What would the series become if I took the absolute value? 2 over 5 to the n. Does that converge? It does converge. Why? Geometric with an R of 1/5 or 2/5? 1/5, which is less than 1. Because the positive term series converges, what would I conclude about the alternating? It absolutely converges. The alternating series converges absolutely. So the absolute convergence question is a yeah. Okay, now the conditional convergence. Like I said, this is, I mean, if I had geometric, I wouldn't even be doing all this mumbo jumbo. But they're trying to give me the practice, I guess, so I'll go for it. Is it alternating?
Wait, yes. Why can't you just say because it absolutely converges it?
Conditionally converges. So that's a theorem we haven't proven yet, but it's true. Let's get to practice. You're right. Yeah. By Venn diagram done. No, let's go for it. Is it alternating?
yes.
It is. Is it true that the n plus 1th term, let's see, we got 5 to the n plus 1 is greater than 5 to the n. I know that to be true. So jumping straight to 2 over 5 to the n plus 1 is less than 2 over 5 to the n. That would be true. And therefore, the terms do decrease when choosing. Okay. Therefore, actually, one more thing, the limit of the terms, do the terms go to 0? That's a yes. So we would also conclude converges condition.
It's not the absolute value of it, right? It's just for divergence theorem.
So it actually wouldn't matter either way, because whether you include the negative or not, it's about do the numbers decrease to 0, and it wouldn't matter if it was negative, positive, going back and forth, going to 0, or all positive, it's the sign. All right, question on 137. 12. 20 and 22. 25.
No,
Five. Boy, what would we do without you in all these questions? All right, here we go.
Has it inclusive on?
Whoever has 12, are you still with me? You still on 12?
Yeah.
Okay.
So then you don't, since it's close on both ends.
All right. I'm not going away. So this is not alternating, so it's not that kind of thing. It's just, does it converge? What did you go with? Actually, let me, before I ask you that, did you split? That should be
I
something.
tried that.
You should definitely split it first into two series. When the numerator is where the sum is. That's it. So that one should be a first step. Okay? Now that's allowed if the numerator is the sum, if the denominator is the sum, then it's much better. Does that get you going? So what test? Root test. If I use the root test on both, then I get the limit as n goes to infinity of that is 0, which is less than 1. So the first part converges. Do you agree? All right. Now let's play the same idea for the next part. Okay, the second part, the same idea, the root test. So let's, maybe the top needs to be talked about. 3 to the 1 over n over n. What does 3 to the 1 over n go to? What does 1 over n go to? 0. And what does 3 to the 0 go to?
1.
1. So this goes to 1 over infinity, which goes to 0. That is less than 1, so that converges. And so, finite sum plus finite sum means the total converges, yes? Okay, that's a theorem we talked about. Converging plus converging is converging. How about number 20? 20. Euler's method 2.2.
The answer says compare with the logic.
For 8,
Yeah, I said it's
did they say inconclusive?
yeah, no. And then
No, you're thinking the same thing I just did. Sin n over n goes to 1 when the limit you're doing is what? That's when you're taking it to 0, not taking Sin of n over n goes to 1 when n approaches 0. Yeah, and infinity, it's small over huge, which is 0. It passes divergence.
Oh, because sine of something is restricted.
Restricted here, and as you graduate, divide by bigger and bigger. So it passes divergence. The problem is it's an inconclusive direct comparison of absolute convergence tests.
Oh, so you have to build comparison to 1 over n.
Shall I hit that now while we're talking about it? So I would, because it is quasi-alternating, now it's not really perfectly alternating. It has some negatives and some positives, but not in an orderly fashion, because 1 radian and 2 radians and 3 radians, those aren't pretty points. But would you agree that it would definitely have some positives and negatives?
Yes.
Okay. It doesn't matter that it's perfectly alternating, you just kind of universalize that to a series with positives and negatives. So I'm going to look at absolute convergence, because that's what this lesson was referring to, if I remember. Okay, now in this case, I normally do direct comparison, limit comparison test, but in this case direct comparison test is better. Would you agree that sine of n, absolute value, is less than or equal to 1?
Yeah.
And then would you also agree then that if I divided both sides by n, that would still be true?
Yes.
Okay? And if I then took the sum of those, it would be less than the sum of these. Now, this is why they say it's inconclusive. What is the harmonic sum to? It diverges, and so we're getting less than diverging, which is inconclusive. Okay? Okay, 20 then, go back to 20. Do we need 20 still? We point to negative to x initial.
Everyone should find out.
Four iterations for real? That's not very pleasant. Do I still need this? Does anybody still want this?
20 was like so much work. Like
Yeah, that's a stinker.
There were so many like decimals. Are we allowed to use our password?
Yeah, no, actually, if you're smart, you can take IELTS to write your program or something, because it's pretty easy to program whether it's not if you're a program. Oh,
So
all you do, not functional. Yeah, all of it. So let me throw something out to you that I didn't know the calculator would do, but Quentin just told me. So the problem, this might be a time saver for you, okay? So the problem is if the derivative is a function of x and y, then it eliminates the normal f approach that I would normally do when you store the derivative as a function of x, right? But apparently, if you just in your home screen do x times y squared and store that to f of xy,
wait, what?
So x plus squared.
then
Yeah.
do you call up, how do you call up f? What it is called?
Either just add
We're learning
or
Wait,
It
where's
isn't
the letter F?
Okay. So
How do you find these things out?
I just tried it.
try it. That's how all great discoveries of mankind start. Man, there's got to be a better way.
So what do you?
So now let me go this way because this is new. So I think I would then start with. So how do you then start? You start by storing these two.
I just
Do you create a loop or?
So I just did -2 plus f of 2 -2 and then I'm
Do you have to do?
recursively do that thing. You never said.
Okay. I wonder if there's a way to store that outcome and why. I think what's slightly better is if each time you made that calculation at the end, you then stored it to y.
Yeah.
Is that what you did? That was
I
I put that.
did.
Cool.
So
But the problem is the x value is changed.
it is
Well,
to,
what if you just created another function of that like you just have to keep track of all your functions.
so let me think, I think this will work. So let's go with,
Yeah.
so y1, I would type this in. I would go -2 plus f of x1 is what, 2.05? Okay, so -2 plus f of 2.05. Oh, I would think yes, you're right. 2. Yeah. Okay. So 2 -2 times 0.05. Then I think I would store that to y.
Yeah, because 0 is less than 1.
Then I would say call up y
Is that's just 0
plus
point
f of
2 point.
yeah, okay, I think I'm getting 2.05
That's
y.
right. Yeah.
So that's a y.
You're right. You're right. Well, I mean, you're not right, but I get it. But you do have right numbers.
2.05 to 2.0.
Yeah, that's not bad.
Yeah,
That's not bad. That's not nearly as bad as it could be.
Are you talking like that with something else?
No.
Okay, at any rate, it helps me a lot. Now I'm much better at this. Okay, so here we go. 20 check. 22. Question on 22.
Part A.
Yes.
Convergence. And when it's like, okay, plus undefined, it's like, I don't know. You'll have like, I'm like this, I mean, it's like, so I like, right, and then like after, like, plugging in 0.1 now. Which are you doing? Oh, did I do this wrong? Hey, are you? Yeah. Really?
Okay, so if I don't know if you're talking to me right there, but what's the point of doing the limit if it's going to be undefined? We don't know it's undefined until you evaluate the limit. That's the key. In terms of anticipation, I generally use this rule of thumb. If this, think powers, if this power is less than or equal to, greater than or equal to 1, then when I integrate it, it's still going to be in the denominator. And so as I get closer and closer to that point, it'll be diverging. So I kind of know right when I look at it, it's going to diverge. Or it's going to that said, you go through the process, because once you get to here, that's how you eventually see, oh yeah, this is diverging or not. If you're dividing by tiny, tiny, tiny negative numbers, would those be negative? If you were a little less than -2, this would be a small negative number. So that would be, these would approach infinitely large as you got closer and closer. You with me?
It's like, yeah, you're right.
So once you on this problem, he's up a little.
Let me make sure I'm actually thinking about this right. So I'm approaching -2 from below. So if I imagine a number, maybe -2.1. -2.1 plus 2 would be -0.1. And -2 divided by -0.1 would be +20. If I got a little closer to -2, like -2.0001, then this would be more like -0.01. So -2 over -100 is +200. So it feels like this is getting infinitely large as we get closer and closer to 0. After that, it doesn't matter that I'm adding -1, or maybe even later that this is approaching some other infinity. These can't be combined, it's just that.
You would count the negative and all of the negative being like undefined.
Yeah.
Still be the first one.
I feel like undefined is not, I feel like diverging or infinite. Actually, Actually, I take that back. Indeterminate would be better. We can't really know what it approaches unless I know the rate at which this grew or the rate at which that shrunk.
So is the part that like you did negative with the arrow going down, is that less than 1/3?
I hope it's negative infinity, because otherwise I should have got an answer of positive infinity. But this,
So like.
this is positive. Oh wait, is this indeterminate or is it just infinity?
The answer I think says limit undefined the original integral divergence.
Let's see. If I were approaching -2 from above, that would be like -1.9. This would be positive, so this is positive infinity.
Just like there, not.
So it feels like this is not indeterminate, it's positive infinity. Huge plus huge.
The answer like on the sheet says like limit undefined original integral divergence.
Diverges means it doesn't approach a finite sum, which it doesn't. It approaches an infinite sum. Okay? Don't get lost in the vocabulary. If you say infinite or diverging, that's good. All right. 22 is done. 25.
I just need to draw a picture or like how, like I got the points.
Okie dokie.
Gives me my count.
So, you know a shape of a x cubed graph.
Ask him.
18x cubed plus 15x squared plus 16x squared. Big idea is that the derivative would be a parabola, right? The parabola could have no real solutions, in which case the original cube would have no horizontal tangents, and the graph would look something like that. The graph, a quadratic could have one real solution. It's possible you could have only one real solution, in which case one horizontal tangent, the graph would look like that. Or it could have two real solutions, or two horizontal tangents, the graph would look like that. Which case did you have? How many real zeros did you have? Did you have extrema?
Yeah, two. Like
Okay.
a minimum and a maximum.
All right, so we're looking at this case. So
then you just like draw that.
So you know the x's. You probably, if you're going to graph it, you probably want to know the y's at those x's. So you know what I'm saying? So I know the y. For example, I know the y-intercept is -5. That's easy. I don't really. I can find the zeros. I don't care. For the extrema. So where were the x's of the extrema?
Negative 0.88.
Okay. Yeah. And what's the y at that point?
I'm just using attacking Bill while we're
8.
and I'm getting a lot of stuff.
Okay, so your max would be something like there. And what is the other extrema? The mid?
Yeah, 0.3.
I know. Every time I actually stop.
Oh. You follow? Just hit them in the max. Maybe throw in the y-intercept for fun. Oh, good.
And then
You know what? Oh, inflection.
where is the double?
Where is the inflection point? Where is it?
Negative 0.277.
Okay, there. That's where it changes concavity. Boom. We're good. Okay. Number 5. Is 5 still a question? I don't even know who has 5.
That was for me, but
You're good?
no, I'm not really good.
You're not good?
Like,
You're not good. So, this is what we learned yesterday.
I watched the video.
Did you? How was it?
It's good. I was just laughing. I'm not coughing. So I got distracted from the list.
That was unfortunate. Okay. We'll crank this out. Have a good weekend, people. So the first thing you should do is check continuity.
I wish I could do like
this guy ends at, this guy leaves off at y x, this guy leaves off at negative 2, 2. This guy picks up at, this guy picks up at negative 2, 4, so it's definitely not continuous at negative 2. This guy, when this guy ends, it's at a y of 2. But when this guy starts, it's at a y of 4. See what I mean? Like that. And this guy, yes. Oh, yeah, that's a lot. Are you with me here? Yeah. I'm just plugging in the n value into the function itself to see the last y on that function. Right?
So it'd be at 1.
Right. So the graph looks something like that, right? Okay, so if you're going to integrate negative 4 to 4 in a piecewise, you'd first say, well, negative 4 up to 2, negative 2. Now, because that function's not continuous at that endpoint, you'd have to create an A and say the limit as A goes to negative 2 from below, and I'm talking the region from negative 4 up to that endpoint A. You with me? Because this didn't include negative 2, I have a discontinuity there. All right, the next region actually includes the endpoints from up to, so I don't need a limit there. I can just say that is the integral from negative 2 to 1, like that. And then the last region does not include the endpoint, so I would have to do a limit as b goes to 1 from above, and go from b to negative 4, positive 4, to do this well. Do you follow?
Yeah.
By yeah, do you mean no or oh yeah?
Yeah.
Okie dokie.
Mr. Rickman,
Yeah.
can you go over number 6?
Sure.
I was gone for that day you went over the milk.
Sure. No problem. I can do that. I'm gonna go. Are you okay with that?
Yeah.
Good. I am gonna kind of say it a long way, but then we'll have a good weekend. Thank you too.
That's right. Alyssa, cover those shoulders.
I'm gonna go through it a kind of longer way, but work towards a shortcut, right? So, if I want F5, then in essence, then I want to differentiate that integral. I looked at the wrong one. Oh, 137, yeah. Isn't it? Oh, I'm looking at, yeah, no, I'm looking at, oh, I looked at the wrong limits of integration. Sorry. Those are the limits for 7, but the function for 6. 3x squared to log of x. Do I have that right now?
Yeah.
Hi.
Hi. Can I get Alethea's set of roots?
Sure. So I am going to. She just got to 2, is that correct?
That's right.
So here's 2. Thank you. Okay. So here we go. I want to differentiate. The question is, what's the derivative of this? Cool. Now, really, in essence, then I need to do 3 things. I would first, before I can take the derivative of this, I would need to know what this is. So I would leave the derivative off for a second and I would focus on the symbol. Now when I do an integral, first find the antiderivative. Now, technically, I don't even really, this doesn't have an antiderivative, so I'm just going to let F, capital F, represent the antiderivative of whatever. I'm just going to call it capital. I would take the antiderivative at F, and then I would evaluate it at the upper limit and the lower limit, right? Okay.
Yeah, I got
After I had done the integral part, then I could take my derivative. Now the answer to the question, when I take the derivative of this guy, the first part is, it's going to be a chain rule. The first part is the derivative of the antiderivative with this in it. Well, the derivative of the antiderivative is right back to the original function. But what is in it instead of a t is then by chain rule, after I took the derivative of the outside, I would then take the derivative of the inside, which is then when I went to this guy, I take the derivative of the antiderivative, which is just the function sine of blank squared. But instead of t, I'm putting but then again, by chain rule, I would then take the derivative of the inside, which is all right.
I'm just,